All right, welcome. Today, we're going to dive deep into one of the most critical topics in all of cybersecurity, authorization flaws. We're going to break down how they work, how the pros hunt for them, and most importantly, how we can all get better at stopping them.
So let me start by asking you a question, one that gets right to the heart of this. When you are using an app, any app, social media, your bank, whatever, can you access someone else's private data? If the answer is yes, well, you've just stumbled upon an authorization flaw.
So here's the game plan. We'll start with the absolute basics of what authorization even is. Then we'll get into the two big categories, horizontal and vertical escalation. From there, we'll level up with some advanced hunting techniques, and finally, we'll talk about how you go from finding a bug to actually getting it fixed. Okay, let's get into it. What is authorization really? Because before you can even think about breaking it, you've got to understand what it's supposed to do. And at its core, it's pretty simple. It's all about controlling who can do what. Now, this is absolutely crucial. People mix these two up all the time. Authentication, that's just proving you are who you say you are. You know, your username and password. But authorization, that's what happens next. After you're in the door, authorization decides which rooms you can enter. Think of it like a key card for an office building. Authentication is swiping your card at the front door to get in. Authorization is what determines if that same card can open the CEO's office. Let's dive into our first major type of flaw, horizontal escalation. And this usually shows up as one of the most famous, most common bugs out there, the insecure direct object reference, or what everyone just calls an IDOR. So the main idea here is moving sideways. You're not trying to become a super user or an admin. Nope. You're just a regular user, and you're trying to access the data of another regular user. The business impact for this one is just massive. We're talking huge data leaks of very private, very sensitive information.
So how do you actually find these? Well, there's a really simple, systematic way to test for it. We call it the Alice and Bob method. It's easy. You just make two accounts. As Alice, you create something private, maybe upload a photo. You grab the ID for that photo. Then you log out, log in as Bob, and you try to access Alice's photo using that ID you copied. Simple as that. And in the real world, this can be just shockingly simple. So imagine you're Bob, and you're looking at one of your own documents. The URL ends with something like document/54321. What do? You just change that number in the URL to 12345, which you know is the ID for Alice's document. If her file pops up, boom, you've just found a classic IDOR.
Okay, so looking at another user's data is bad, for sure. But what if you could do more? What if instead of just moving sideways, you could move up? What if you could get the keys to the entire kingdom and become an administrator? Well, that's vertical escalation. Yeah, this is all about climbing that privilege ladder. It's when a regular, everyday user finds a way to do things only admins should be able to do. Things like deleting other people's accounts, changing settings for the entire website, or reading sensitive system files. An attack like this can be completely devastating for an application. Game over.
So where do you even look for these kinds of flaws? Well, hunters usually have a few go-to techniques. You can dig through the website's JavaScript files, looking for secret links to admin pages. You can try to just guess the URLs, by brute forcing common paths like /admin. Or you can get a little fancier and start manipulating the actual data in your requests to the server. And again, you're going to see a theme here. Sometimes the vulnerability is just sitting there in plain sight. You can use a tool to intercept a request your browser is making, and you might see a parameter like user level. Or maybe you just try adding one yourself, like admin equals true. If the server is built to just blindly trust that input, well, congratulations, you've just made yourself an admin.
All right, so we've got the fundamentals down for horizontal and vertical attacks. Now let's get into the really fun stuff, the edge cases and advanced techniques. This is the kind of thinking that separates the beginners from the expert bug hunters. You gotta remember, developers don't always use nice, simple numbers for IDs. Sometimes they're encoded in formats like base64, or they use these super long, random-looking UUIDs. You have to test for all those variations. Also, keep an eye out for nested resources, where you might have to change two different IDs in one URL to get it to work. And here's a pro tip. Always try different request methods. Just because a GET request is blocked doesn't mean a delete request is. Okay, so check this out. This is what these advanced techniques look like in the wild, on a real API test. First, you see the normal request. Then, the tester tries a simple IDOR by just changing the number. That fails. But they don't give up. They then try a much more complex hash-based version. It just goes to show you have to be persistent and creative. So you found a bug. That's awesome. But believe it or not, you're only halfway done. Finding the flaw is one thing. Communicating it clearly so someone can actually fix it, well, that's what protects users. And in a bug bounty program, that's what gets you paid. And this really gets to the heart of it, you know? It's easy to get caught up in the puzzle of it all, but we can't forget why we're doing this. The real goal is to make the internet a safer place for everyone by helping companies find and fix these critical security holes.
So what does a great report actually look like? It's all about clarity. It's about making it so dead simple to understand that anyone on the security team can follow your steps and see the bug for themselves. Look at this example. 1. Create 2 user accounts. 2. Log in as user A. It leaves absolutely no room for doubt.
A truly exceptional report doesn't just say, hey, this is broken. It provides a whole roadmap for fixing it. You give them a tiered plan. First, the immediate critical patch to stop the bleeding. Then, a short-term plan to audit for similar bugs. And finally, a long-term architectural change to prevent this whole class of vulnerability from ever happening again.
And the craziest part, the immediate fix is often this simple. I mean, look at that line of code. All the developer has to do is add and user ID equals question mark to their database query. That's it. That one little check makes sure that the person asking for the document is the person who actually owns it. One line of code stops the whole attack. So at the end of the day, authorization controls are the silent gatekeepers of all our private data online. They're surprisingly easy to get wrong, but with a methodical approach, you can find them, you can report them clearly, and you can help build a safer web for everyone. The only question left is, where are you going to start looking?